Okay, so let's do some examples of vector triangles. We'll solve these in the normal way, and then we'll see how that compares to our vector triangles. So for A is pretty simple. We're going to resolve vertically. Okay, and that means I've got P in the positive direction, and that is equal to 5 sine 30 in the negative direction, and 5 sine 30 is 2.5 newtons, so that's P. Okay, we'll go horizontally. I've got Q in the positive direction, and that's equal to 5 cos 30, which is 5 root 3 over 2, which we round to 4.33 newtons to 3 sig figs. Okay, B. B's a bit trickier. So now B, what have I got? If I go in the vertical direction, I've got 7 sine of 35. I've also got P sine of theta. And then that is equal to 8 cos of 40. Okay, if I go horizontally, I've got P in the positive direction, but that's P cos theta. And I've also got 8 sine 40, and then that's equal to 7 cos of 35. Right, so now I've got two unknowns. I've got P and I've got theta. So what I'm going to do, from equation number 1, I'm going to make P sine theta the subject, and that means it's equal to 8 cos 40 minus 7 sine of 35. And from equation 2, I'm going to make P cos theta the subject, and that means it's 7 cos of 35 minus 8 sine of 40. Right, now as we've done before, I'm going to divide equation 1 by equation 2 to get tan of theta. And tan of theta equals 3.57122 by dividing those two equations. And therefore, theta is equal to 74.4 degrees. Now I need to find P, so I'm going to substitute it back in, or I'm going to substitute it back into 1. So instead of P sine theta, now I've got P sine of 74.4, and that is equal to 2.11332, and that means that P is equal to 2.194, which the 3 sig figs is 2.19 newtons. Right, now, can I do the same thing with vector triangles? Yes, well, from A, we can see I've got a vertical and I've got a horizontal vector. Well, we know that they are always perpendicular. And then we've got a slanted one of 5 newtons at 30 degrees. So we turn that into a right angle triangle. And now I've got to try and work out what P and Q are. So that means that P is the opposite side. So I know that the opposite side is equal to the hypotenuse times the hypotenuse times sine of 30, because remember from SOHCAHTOA, so I do the hypotenuse, 5 times sine of 30 equals P, and 5 sine 30, as we saw before, is equal to 2.5 newtons. Okay, now if I want Q, I know Q is the adjacent side. Again, I look at my hypotenuse, I look at my SOHCAHTOA, and I do my hypotenuse, 5 times cos of 30. 5 cos 30 is equal to 5 root 3 over 2, which again will round to 4.33 newtons. Okay, so for B, you can see we've got 8 newtons coming down diagonally in this direction, P going this direction, 7 going in this direction. So we rearrange them into a triangle. So I've got 8P and 7. Okay, and I can now, because I've made it a triangle, I know 3 lengths, but I don't know any angles. So what I'm going to do, the first thing I'm going to do is I'm going to use the cosine rule. So I know that Pn is the side that I want. So Pn squared is equal to 8 squared plus 7 squared minus 2 times 8 times 7 times cosine of 15 degrees. Okay, because you can see as I've arranged them, I know that this is 35 degrees. I know that this is 40 degrees. So together they're 75. I know that the horizontal and the vertical are perpendicular. So that only leaves me with a part in the middle, which must be 15 degrees. So now I've got that. Remember, the angle you know has to be between 2 sides that you know. So now we've got that. Okay, so that means that P, when I square root it, that side Pn is equal to 2.194, which is 2.19 newtons. So we've used the cosine rule to find that. Now I've got to find theta. So now I'm going to use the sine rule. So for the sine rule, remember I need one side opposite an angle I know. Well, now I know an angle and a side, which is 15 and P. So now I know that sine of 15 over 2.19 is equal to sine of theta over 7. And I can find out the angle at the bottom. And that tells me that sine of theta, and therefore theta is equal to 55.67. That's the angle at the bottom. Okay, don't necessarily need to know that, but now I do. So now if I do the other angle, sine of 15 is equal to 2.19, and that's equal to my third angle, sine of theta, over 8. And then that means theta equals 70.69 degrees. Okay, now I know that this angle is 35 degrees. So I know that I need to take that away. But if I take 35 degrees away from 70, I've got a very small angle. So one thing we have to bear in mind is that as this is sine, there are 2 solutions, 2 positive solutions. If I've got a solution at 70.69, I also have another solution at 180 minus 70.69, which is 109.311. Okay, so actually, if you think our triangle's got to add up to 180, which means that that third angle has got to be 109.33. And then when I subtract my 35, which I know, I get an answer of theta equals 74.4 degrees. So you can see sometimes basically it's easier to do it resolving it vertically and horizontally, like A. B was trickier But again, it depends on how many unknowns we've got as to which version you want to use. But it's another tool for our toolbox.